Okay, so let me share my screen now. We commence tonight's class from where we stop, and I think so far now we have been able to cover if I'm not mistaken, we have been able to cover up to 4 topics. Can you guys see my screen now?
Yes, sir.
All right, so this is where we stop in the afternoon under vector and scalar. And I'm glad that majority of us we are able to answer questions that was posted on this particular topic. All right. By grace, we are going to commence now by looking at the next question from our past question. So let me just open the past question. I know where we stop. Okay. So we've been able to answer question number 5. So we are on question number 6 now, and the question is: an object of mass 2 kilogram moves with a velocity of 10 meters per second around a circle of radius 4 meters. Calculate the centripetal force on the object. All right, so this topic now is strictly under circular motion. So that simply means that we have to consider the topic circular motion. Circular motion. Now, when you talk about circular motion, what exactly do we need to understand about this motion? Number one is that we need to understand the condition that makes a body perform a circular motion. I want you to pay attention to this. And guys, you can see that the way I'm summarizing these topics for you guys, it's not like a real summary, in the sense that I'm trying to go deep as possible so that whatever the problem might be, you will be able to handle it. I believe we are following. Please, if you are following, can you
Yes, sir.
okay. So
Yes, sir.
yeah, thank you. I'm trying to go deeper so that you will understand those topics extensively. The difference between this and what you are going to have in a class is that I'm not dictating much notes. I'm just explaining those facts. But I'm not leaving any stone unturned rather. So, number one thing under circular motion is that you must understand the condition that will result to circular motion. Number two is that you must know the force that produces a centripetal force. Force that produce centripetal force. You must know that. Number three that you need to know is calculation on it. So you must understand various type of calculations under the concept of circular motion. It's very, very important. Is that taken now? All right. And I think we can commence the class now. So we're going to look at different types of circles, both vertical and horizontal. Without any further ado, let's get started. Now, what is circular motion? For you to understand what is circular motion, I want you to understand that if you have an object, for this object to perform a circular motion, there must be what? A respect to force and velocity. You see, velocity and force, when you have them acting on a body and they are facing the same direction, that is when the velocity vector and the force, when they are facing the same direction, what will happen to the speed is that the speed of the object will increase. Are we there? And when you have that velocity and the force that is acting on a body, if they face opposite direction, what will happen to the speed of the object is that the speed will decrease. So what happens if velocity is perpendicular to velocity? We have that velocity is perpendicular to velocity. What will happen to the speed? The speed of the object is going to be constant. Or is it going to be constant only? No. Whenever you have that force is perpendicular to velocity, the speed will be constant, and that force would cause the body to move in a circular manner towards the direction of the force. You see that this force is going upward and the velocity is going like this. So whenever the velocity is perpendicular to the force is going to cause the body to move in a circular track towards the direction of the force. So now let's take for instance that when the body gets to this place, you still have that force and velocity, they are perpendicular. This force will also cause this body to move in the direction of the force. So if getting to this place, the force and the velocity are still perpendicular, this will cause this body to move in the direction of the force. So if you look at this now, you see that this procedure would continue. This procedure would do what? Would continue, and at every point you will see that the speed is what? The speed is constant. The speed is constant. The velocity is also constant. The velocity is constant, but is what? Is varying in direction. And you can see that the force is always towards the center. Please, do you understand what's happening here now? You have a circular motion because the force is perpendicular to velocity. And for anybody that is performing a circular motion, the speed is said to be constant, the velocity is constant, but the direction is changing. So, and its acceleration, sorry, it's the force is also what? Towards the center. So you can see this now for a body that is performing a circular motion now. Now, this force that is pointing towards the center is what we call centripetal force. Centripetal force. Are we guys getting this explanation now? I'm trying to take it bit by bit so that you don't find it too overwhelmed. So the speed is constant, the velocity is constant, but the direction varies. The force is towards the center, and that force that is towards the center is called centripetal force. Now, when you look at this velocity of a thing, you will see that at every point in time, it is tangential to the curve. See that it is tangential to the curve at every point in time. So that means velocity is always tangent to the parts in which the body is moving. We understand all these characteristics now. Now, there is usually a certain kind of question that JAMB will want to like ask about this kind of body that is moving like this. It might be like, what will happen if the string that is causing this body to move circular in the circular orbit, if the string should cut, so what direction would the body move? So if the string should cut, the body is going to move in the direction that is tangential to the path, because the velocity is what? Is tangential to this path. I want you to note that very well. Do you understand this now? Now, let us now what? Look at some definitions of circular motion. Different way in which we can define it. Before we now consider the force that produces centripetal force. All right. So let's take down the definitions of circular motion, or different way in which circular motion can be defined. We can say that it is a motion of a body above a fixed point with constant speed. We can say that it is what? Motion of a body above a fixed point, above a fixed point with what? A constant speed. With a constant speed. When you see this, you know they are talking about a circular motion. You can also say that it's a motion with constantly varying direction. A motion with constantly varying direction. You need to note all these things very well, because these are ways that examiner want to test you on the definition of it. Are we together now? You can also say it is motion with constantly varying velocity, momentum, and acceleration due to the variation in the direction. I'll take that again. You can say it is a motion constantly varying velocity, a motion with constantly varying velocity, momentum, acceleration due to what? The varying of direction. You can also say it is motion with velocity of constant magnitude. We can say it is a motion of velocity of what? With velocity of constant magnitude. You can also say it is motion with acceleration of constant magnitude. I want you to put all of these things down. I'm tired of writing, that's why I stopped writing. You can say it is what? Motion with acceleration with acceleration of constant magnitude. I get to this now. You can also say it is motion with velocity directed along the tangent to the path, while the acceleration and force are directed towards the center. What I'm trying to give you,
So please say it again.
okay, you can say it is motion with velocity directed along the tangents to the path, while the acceleration and force are directed towards the center. You can take it like that. You can also say it is motion with acceleration perpendicular to the direction of the velocity. It is motion with acceleration perpendicular to the direction of velocity. And lastly, you can say it is motion of a body with no work done. With no work done, as movement is about a fixed point. I'll take that again. You can say it is motion of a body with no work done, as movement is about a fixed point. Do you guys understand this now? Now,
Yes, sir.
Yes, sir.
now, should I tell you reason why I break the definition down to all of these parts instead of what you have in your textbook? You know, in some of your textbooks, you have that circular motion is a motion in a circular path in which the speed of the body remains constant while its direction continuously changes. That's the definition that you have in most of your textbooks. But why do I decide not to give you that definition? I decided not to give you that definition because that definition is not going to help what? JAMB to test you well. And that's why I break it into definitions that JAMB might want to use to test you. Before we proceed to forces that are responsible for centripetal force, I would like to bring up some questions to verify all these definitions. And I want you guys to respond to them before we move on. Are we ready?
Yes, sir.
Yes, sir.
Okay. All right. So let me try and come up with questions under this particular case of definition so that you are going to understand how examiner tends to like question you with all of these definitions. Okay, I'm coming. Sorry, I want to say I'm tired because my daughter is saying she's tired. Okay, sorry. All right, so let me look at this very first one. I'm trying to like see. Okay, all right. There, guys.
Yes, sir.
This question is 1982. 1982, question number 3. And I want you to pay attention. The question says the question says that an object moving in a circular track, in a circle, has an acceleration towards its center. Towards its center. This is provided by a change of momentum. A change of momentum. B, a centripetal force. A centripetal force. C, a centrifugal force. A centrifugal force. D, Newton's force of gravitational. Newton force of gravitational. And E, acceleration due to gravity. Acceleration due to gravity. So which one do you think is going to be the right answer to this question? Are we there? Is anybody seeing the question? Question states that an object moving in a circle has an acceleration towards its center. This is provided by
B.
what do you call it?
B.
Centripetal force, sir.
Centripetal force.
Yes.
So that's it. Okay, so let's look at another one. Look at this one. I'm tired of writing that long text, but let me just read out. I'll write the one that is very necessary though. This is 1983, question 11. So the question says, which of the following statements is or are true about a car moving around a circular track at a uniform speed? Roman figure 1, its acceleration, its velocity is uniform. Remember, when I say something is uniform, it means it's constant. B, it undergoes an acceleration. Roman figure 3, the friction between its tire. Okay, I think this is the next place we are going, so we've not really get there. Its tires and the ground. Its tires and the ground provides the necessary centripetal force. Necessary centripetal. So the question says that which of the following statement is true? A, 1 only. B, 2 only. C, 3 only. And D, 2 and 3 only. And E, 2 and 3 only. Which will be the right answer then?
E.
1, 2, and 3. Okay. I know why you choose E. Okay. So let me quickly buttress something here. You see this one here, that its velocity is uniform. It is the speed that is uniform. Though the velocity is constant in terms of magnitude, but in terms of direction, it's not constant. Am I making sense now?
Yes, sir.
So in terms of direction, it's not constant. And you know, what differentiates velocity and speed is direction. So for that reason, when they say velocity is constant, they are referring to that velocity as a speed. Are you getting it now? They are not supposed to call it velocity. So velocity varies, though the magnitude is constant. So Roman figure 1 is not correct. Are you guys following? Roman figure 2, it undergoes an acceleration. That's true. Towards the center. And Roman figure 3 is also correct. So the correct answer is supposed to be D. That's Roman figure 2 and 3. All right. Not really seeing the question that I really want. All right. I think this one is making sense. 2000, year 2000. Question is from year 2000. And the question tells Roman figure 1, its velocity is constant. I think we are trying to ask us now. Roman figure 2, no work is done. No work is done on the body. Roman figure 3, it has constant acceleration. That's constant acceleration. That's constant acceleration. Direction away from the center. Direction away from the center. Roman figure 4. The centripetal force is directed towards the center. The centripetal force is directed towards the center. Directed towards the center. So the question says, which of the above is true of a body moving with constant speed in a circular track? You can see the way they are putting this now. Which of the following is true of a body moving with a constant speed in a circular track? A, Roman figure 2 and 4. B, Roman figure 1 and 4. C, Roman figure 2 and 3. And D, Roman figure 1 and 3. So, which one do you think is correct?
A.
A, that's Roman figure 2 and 4. So, you see, the velocity is constant. It is,
Yeah, A.
yeah, correct. It is speed that is constant, not velocity. No work is done on the body. Yes, that's true. It has constant acceleration directed away from the center. No, it has a constant acceleration directed towards the center. It's not away from the center. The centripetal force is directed towards the center. So that's what makes A correct. So there are other questions like that which you are going to have in the group. So let us save time so that we can cover the necessary things to cover under this topic. I want to believe that everybody understands this now.
Yes, sir.
Yes, sir.
All right. So let us quickly look at the forces or factors that produces centripetal force, because this is very important for you to know. In some cases, when you are given question, we all know that centripetal force is given as mv squared over r, and centripetal acceleration is given as v squared all over r. You see, this formula for centripetal force, mv squared over r, is something that is not going to work always. Am I making sense now? So because it's not going to work always, there is need for you to understand the force that is producing it. Because if you don't understand the force producing it, in a case where it's not going to work, for example, if I'm talking about the planet, and I told you that the mass of the moon is A in kilogram, and the mass of the earth is B in kilogram, and the radius, that is the distance between the moon and the earth, between the center of the earth and the moon rather, is, let me say, m centimeter or m meter or kilometer, as the case may be. Are you getting me now? And I'll say, calculate for the centripetal force. The guys, do you see that question now? I gave you mass of the moon. You are given mass of the earth. You are given the distance between the center of the earth and the circumference where you have the moon. And you are asked to calculate for centripetal force. You see, in this case, you don't have anything like v squared. No, you have r. And you have two mass instead of one mass. In this case, how will you know how to calculate for centripetal force? So because of all these kind of scenarios, that's why you need to understand the force that is producing the centripetal force itself. Are we together now?
Yes, sir.
Okay. So I'm going to consider this in 3 ways. Let me say 5 ways. Are you there now? Let me say what? 5 ways. So that it will go a long way for us. So let me first of all clear this. If you have a stone, are you getting me now? You want to wheel a stone now. You want to wheel a stone. And you attach the stone to a rope. Let's say this is the rope. I see this now. And you attach a stone to it. This stone is of mass m. You are now wheeling the stone like this. What will produce the centripetal force that will allow this stone to remain in this circular track? That centripetal force is going to be produced by the tension in the rope. Are we together now?
Yes, sir.
I get following.
Yes, sir.
It's
Yes,
not,
sir.
I'll need your response often. I'm kind of weak. Are you getting it now? And I want the class to be interactive so that I'll become energetic. Are you getting it now? So please, let us just try.
Yes, sir.
Help me like that. Now, the second one, we have seen the first cases now. The first case now whereby you attach a stone to a rope and you are wheeling it. So while wheeling the rope, what happens? The centripetal force is what is produced by the tension in the rope. So in a case whereby you are given a tension force and you are asked to calculate for centripetal force, if the scenario is like this, then you can say the centripetal force is equivalent to the tension force. Now, the second case is a case of when you have the planets. Let's say this is the Earth. I following, and this is the moon that is moving around the Earth. Now, the force that keep this moon to keep on moving in this track is the force of gravity. That is the force of attraction between the Earth and the moon, what we refer to as gravitational force. That is what keep this moon to continue moving in this circular orbit. Just like the force of attraction between the sun and other planets. So it is force of attraction between the sun and other planets that enables other planets to continue moving in that circular orbit. Therefore, what produces the necessary centripetal force for this object moving around this orbit is what? Is gravitational force. So in the first example that I cited, this is the reason why you can just calculate for the force of gravity and it's equivalent to what? Centripetal force. Now the third case, I think I might need to do some proving here so that you know how to go about it. Of course, we know how to go about tension force. We know how to go about gravitational force. And this one, if you have a car that is moving around a roundabout, let me draw a car that is moving around a roundabout like this. So this is a car now, and this car is moving around like this. What enables this car to continue moving along this circular track is what we call friction. Are you getting it now? It is the friction between the tire of this car and the road that provide what? The necessary centripetal force that keeps this body moving in this circular track. So in that case, we can say centripetal force is equal to what? Frictional force. Are you getting this now? Let me indicate this with frictional force, mu times R.
Yes, sir.
Yes, sir.
All right. Now, another case, this one can be EMM all over D squared. And this one is mv squared over R. Okay. Now, I said I want to do some proving. Let me quickly show you guys what I said I want to prove. Let's take, for instance, that this always happens much with a bike man. I don't know if you have seen where all these bike man, they are trying to use a bike to ride circle. Whereby they are really showing their talent in riding bike. They just place the bike and just use it to write O on the ground. Now, in order for that bike not to fall, if I ask you that at what angle should the bike man place the bike in order for the bike not to fall while trying to write O, what will be the angle? Do you guys understand what I said there?
Yes.
All right. So for you to see
Please
what
repeat. Yes, sir.
now, for you to be able to detect that angle, you must understand that the frictional force That is mu times r is equal to the so-called centripetal force, which is mv squared all over r.
Yes,
Yes,
sir.
sir.
Now, this mu that you are seeing here and this r, which is normal reaction, the r, I can rewrite it as mg, which is mass times gravity, since it is normal reaction. And this will equal to mv squared all over r. So the mass can cancel each other. And now we have that mu multiplied by gravity is equal to v squared over r. So divided by g, you have that mu, which is coefficient of friction, is equal to v squared all over gr. The question is, at what angle will the bike man place the bike? So for me to get the angle, I need to recall that what the mu, which is coefficient of friction, is given as tangent of theta. So if I replace that, I will have that tangent of theta is v squared over gr. So if that should be the case, the angle that we are looking for is going to be arctan of v squared all over gr. Whatever result you have here is going to be the angle that the bike man needs to place the bike in order not to fall. So do you get that now? All right. So try to quickly take this down. So take it down and let's look at
Yes, sir.
the remaining two cases. And these remaining two cases, I want to look at it in terms of the type of a circle. When you are wheeling a circle vertically and when you are wheeling a circle horizontally, how do you determine the centripetal force? Very important, you know. Okay. All right. So let me just wipe off some part of the board. Now, if you have a circle that we are wheeling horizontally, this is an horizontal circle. How do you determine the centripetal force needed? In a body horizontally, if you are wheeling it very fast, you have that the tension in the rope is equivalent to centripetal force, which is the first one that we have. But if you are wheeling it slowly, you will have that the tension force is slightly away from the center. If it is slowly, it's approximately away from the center. It's not as if it's that much away, but let me just show you, just like this. Something that's supposed to go straight like this. Are you getting it now? So this is the tension force here. Let me call it T. And then it has a vertical component now. So this is Ty and this is Tx. So along this horizontal axis, this is the centripetal force. Along this vertical axis, it is the force of gravity. So if I really want to get the tension that is providing the necessary centripetal, I will have to apply Pythagoras theorem. That is, T squared is equal to Tx squared plus Ty squared. And that will give me that T is equal to the square root of Tx squared plus Ty squared. A body that is wheeling along a horizontal circle. So this is the tension force along the horizontal axis, which is approximately centripetal force. And this is going to be what? Mg. So I can say T is equal to the square root of mv squared all over r all squared plus mg all squared. Have we taken down all these equations? These are very important key to remember and to note under centripetal force. So in this case, you have that the centripetal force is equal to the square root of mv squared over r all square plus mg all square. Now, in a case whereby you have it to be extremely away from the center, if you have it to be extremely away from the center, then the centripetal force can be Fc equal the tension force plus mg cos theta. I want us to note all these equations. They are very useful, and we're going to look at questions on them. All right. So let me wipe all this off. Have we taken it down before I wipe it off? I want to look at the vertical circle now. If the circle is given in a vertical direction, like if you are wheeling it on in a vertical way. So now let's say you are wheeling the circle vertically. Since my network went off and is no longer present. So can we see the screen back?
Yes, sir.
All right. So the third one is, sorry, the last one that I want to consider is if you are wheeling a circle vertically, you are rolling it vertically. Now, if you are rolling it vertically, it has three cases. Let me say this is point A, this is point B, this is point C, and this is point D. So what the centripetal force here will be, that is the force that will cause this body to turn. For you to know it, you need to consider that, is this body going to be heavy at this point or is going to be light? I'm asking now, if I want to move this body upward at this point that it is, now I'm talking about point A. If I want to move it upward, is it going to be very easy? That is it going to be light or is it going to be heavy? I'm asking.
Heavy, sir, I think.
Yeah. So it's going to be very heavy for me to lift it. Therefore, the kind of centripetal force I'm going to have here, or what the tension force in this rope is going to be, is going to equal to the centripetal force plus the weight of the object at this point, which is the bottom line. What will happen if the body gets to point B? You have to know all these things. When the body gets to point B, it is approximately what? Centripetal. So the tension here is going to be, sorry, I'm not supposed to put the C. The tension here is going to approximately be centripetal. And when it gets to this point here, to fall down to this place, is it going to be easy or is it going to be hard? I'm putting the question to us now. It will be easy, right? So the body will feel
Easy, sir.
Yeah, the body will feel lighter to fall down here. For that reason, the tension force here is going to be centripetal minus what? Mg. Because the force of gravity will help you to pull it down. You see, at this point also, the tension force is approximately centripetal force. Do you understand this now?
Yes, sir.
All right. So before we wrap it up on this, let's quickly show some useful
Yes, sir.
equations. Let's quickly show some useful equations about this now. You have to understand that when you're having a vertical circle, these are the conditions for the value of the tension force at every point on the path. So there are some other advanced aspects of this topic that it's not really necessary. Like if you are considering a pendulum that is suspended vertically, For example, if I have um, if I have something like this, let's say the length of this rope is L, and then I I decided to pick these points and I set this body in a circular motion like this. That is, this body start moving in a circular path like this. Remember, this is length L, and this is an angle of theta. Are we together? So here, what can you say about the tension force that is causing this body to move? So we have that because the tension force is going to be from here to here. So this is going to be T. Are you getting it now? So for you to get the value of what this is going to be, then you're going to be having that T sine of theta is equal to the centripetal force mv squared all over r. I can also have that T cos of theta equals to mg. Are you getting this now? So if you take the ratio of these two, you can have that the tangent of theta is equal to v squared all over gr, what we proved earlier. Am I making sense now? And from here, you can go as far as expressing v squared in terms of angular frequency, but I don't think you really need all of this. So let us just leave it for those that need it. So let me back to what you really need. So I want to come up with some useful equation for you under circular motion. Then we'll look at questions on it. Then we can call it a day. All right. So what are the useful equation I want to recall? For the first one, centripetal force is given as mv squared all over r. And we have that centripetal acceleration is v squared over r. Then we have angular velocity to be all over t. All together now. So that is angular velocity is what we define as as the change of the angle per seconds. So the change of the angle per seconds is what we refer to as angular velocity. So if this body move completely, that is, if it completes one circle, omega is going to become 2 pi all over t, isn't it? So we have that omega equal 2 pi over t, and you know that t itself is equal to 1 over frequency, and frequency is also 1 over t. For that reason, you can say omega is 2 pi f. So another equation you need to know is the relationship between omega and the linear velocity. Is that velocity is equal to omega times r. Are we together now? Omega multiplied by r is what will give us frequency. Was it supposed to be omega or omega square r? Let me try and figure it out. Okay. I think linear velocity is given as omega r. Yeah. I can't see where I'm going to, but I think it is. Yeah. Yeah, it is omega r. So if this is linear velocity, then we can say that our linear acceleration, which is v squared over r, is the same thing as saying, acceleration due to gravity. Centripetal acceleration is v squared over r. So this can be written as omega squared r squared over r, and this can just become omega squared r. That's for our centripetal acceleration, and therefore centripetal force can become m omega squared r. So we can use this to calculate for our centripetal force. I think all these equations will be a very useful one. And don't forget that frequency can be the number of revolution over time. I guess period can also be time all over the numbers of revolution. So these are the useful equations that I think you are going to be needing as far as this topic is concerned. Now, when you have centripetal force, the opposite of centripetal force is what we call centrifugal. So when centripetal is trying to keep an object in a circular path by being directed towards the center, centrifugal always want to take an object off the circular track by being away from the center. So that's the difference between centripetal and centrifugal. Is that taken up? All right, so can we consider questions now? Okay. All right, so let's consider some questions.
Yes, sir.
So let's consider some questions under this. Okay. 1982, I want us to open our ear, please, because I will be dictating the question. 1982 question number 11. The question states that the force responsible for holding the moon in orbit around the earth against the gravitational pull of the earth is A, centrifugal, B, rotational, C, reaction, D, centrifugal, and D, E, fractional. So which one will be the right answer? The question again is, the force responsible for holding the moon in orbit around the earth against the gravitational pull of the earth is centripetal. Yeah, centripetal. Thank you. That's correct. All right. So another question here is that an object,
D, sir.
Centripetal.
yeah, object of mass 2 kilogram, an object of mass 2 kilogram moves in a circular path, moves in a circular path, move in a circular path of radius 0.5 meter with a speed of 1 meter per second, with a speed of 1 meter per second. What is its angular velocity? What is its angular velocity? Okay. Option A, 8 rad per second. B, 4 rad per second. C, 2 rad per second. And option D is 1 rad per second. Right answer. Say what? 2 rads per second. So that's correct. Okay. So if you look at the question, we said an
2 rad
object.
per second.
We said an object of mass 2 kilograms.
Satsurat.
The mass of the object is 2 kilograms. Moves in a path of radius 0.5 meter. So the radius is 0.5 meter with a speed of 1 meter per second. So the speed is 1 meter per second. Are we there? So this speed now is like velocity. So what is the angular velocity? So angular velocity we don't know. But we know that linear velocity is angular velocity times the radius. Therefore, we have that angular velocity is velocity over radius. And what's our velocity? 1. So you have 1 divided by the radius, which is 0.5. So 1 divided by 0.5 will give you 2 rad per second. You get that now?
Yes, sir.
All right, so let's take another question. So this is 1984 question 22. 1984 question 22. The question states that a particle moves in a circular orbit of radius is 0.02 meter if the speed of the particle is 0.88 meter per second. Calculate its frequency. Calculate its frequency in circles per second. Option A 2.0, option B 8.8, option C 7.0, option D 17.0, option E 17.6. What will be the right answer now?
Sir, 7.0.
So the correct answer is going to be 7.0. Do everybody understand how we get that?
No, sir.
Okay. I hope it's not as if you are not trying at all. This one that you are not getting any of it yourself. It's always try and attempt. The question here states that a particle moves in a circular orbit of radius. So the radius is 0.02 meter. The speed of the particle is 0.88 meter per second. Calculate its frequency in circle per second. So we are looking for frequency. So is there any formula that relates frequency and linear velocity and radius? Absolutely. There's no formula, right? But we know that there's formula that relates angular velocity and frequency together, because angular velocity is 2 pi frequency. There's formula that relates linear velocity and angular velocity together. That is V equal omega r. So instead of this omega, replace it with 2 pi f. We are going to be having that 2 pi f multiplied. Therefore, f is going to be V divided by 2 pi r. Do you understand that equation now? So
Yes,
frequency
sir.
frequency will now be 0.88 divided by 2 times pi multiplied by 0.02. So when you do your math here, you have that f equal to 7. F will be 7 cycles per second. You understand that now?
Yes, sir.
Now 1978. That's why you need to understand how those equations, how they relate to each other, because they will not be giving you direct that you can just find the equation and just use it, bam. No, nobody wants to try you like that, because with that you find everything so simple. So you always need to understand how those equations relate to one another, so that you know what and what to do to come up with the requested answer. All right, so let's look at this next question. 1978, question 11. Well, states that the force required to make an object of mass m traveling with velocity v turn in a circle of radius r. A mv square over r. B mr square over v. C mr over v. D mv over r square, and E mv over r. So which one will be the right answer?
A.
MV square over R.
A.
Mv square.
Over.
That's option. Okay, so let's look at this. 2007 question. Trying to check the number. Question 44. 2007 question 44. Question states that a car of mass 1,500 kilogram goes round a circle, a circular of radius meter at a speed of 40 meter per second. So the magnitude of the centripetal force dash. Option A, 1.2 times 10 raised to power of 2 Newton. Option B, 1.2 times 10 raised to power of 3 Newton. Option C, 4.8 times 10 to power of 3 Newton. Option D, 4.8 times 10 raised to power 4 Newton.
Option D.
Sir D.
Okay, so D is the right answer.
4.8 times 10 raised to power 4.
So virtually everybody get this right. Is Maria in this class? Maria, are you in this class?
Yes, sir.
I think I can identify that voice. Thank God you are able to fight the duo.
Yes, sir, finally.
All right, so 1982, question 11. The question says a ball attached to one end of a string moves anti-clockwise around the circle. Whose center is O. If the string suddenly breaks when the ball is at the point P, along which of the following path will it move? So we have option A, this center O, and we have this to be point P. So the ball move in that direction. That option B is O, and this is the center. We have that P, ball move like that. Just C, we have O, ball move like this. For D, you have the center O, the ball move like this. Which one will be correct?
B, sir.
B.
Option B. So
B.
that's correct, because we know that whenever a ball moves like that, they move tangentials to the path.
Direction, yes.
All right. Okay, so let's try this. I'm tired of writing, so please let me dictate it so that I quickly take it down. An object of mass 6 kilogram. An object of mass 6 kilogram is wheeled round a horizontal circle of radius 3 meter by a revolving string inclined to the vertical. Calculate the tension force. Calculate the tension force in the string if the uniform speed of the object is 9 meters per second.
Sir, please repeat the question.
An object of mass 6 kilogram, an object of mass 6 kilogram is wheeled round a horizontal circle. Is wheeled round a horizontal circle of radius 3 meter by a revolving string inclined to the vertical. Calculate the tension in the string if the uniform speed of the object is 9 meters per second. Take G equal 10 meters per second square. So option A, you have 27 Newton. Option B, 4 Newton. Option C, 162 Newton. Option D, 173 Newton. So which one will be the right answer, please?
C.
That's 162 Newton. Have you cross-check your result very well? Kindly cross-check. Any answer that contradicts that?
Sir, 173 Newton.
173 Newton. Is that what everybody got? Any other person that got that? Is that what we all get?
C, sir.
I can't hear what to say. Do you say yes?
Yes, sir. C. 162.
162. Why somebody get 173? So let's look at it together then so that we can be on the same page. So because it says an object of mass 6 kilogram, so the mass of the object is 6 kilogram. It found a horizontal circle of radius 3 meter. So the radius is 3 meter by a revolving string inclined to the vertical. Calculate the tension in the string if the uniform speed of the object is 9 meter per second. So V is 9 meter per second. And we have that D is equal to 10 meter per second square. And we are looking for the tension force. All right. So we have that the tension force for a circular body is given as tx squared plus ty squared, where t equal to So it's going to give us mass times acceleration, that is centripetal acceleration, plus this one will be mg. So this one is square. This one is also square. And that result will be equal to the square root of m squared into a squared plus b squared. If that should be the case, the square root of m squared is m. You have that t is equal to m square root of a. What will be our a? Centripetal acceleration. So let's calculate for centripetal acceleration here. That will be v squared over r. That will be 9 squared all over 3. And that will give us 81 over 3. So 81 over 3 should give us 27. So we have 27 squared plus our g, that's 10 squared. Am I making sense now? And the mass is what? The mass is 6 kilograms. So the tension is going to be 6 square root of the 27 square should give us 726. Is somebody should check?
29, sir.
Okay, 729. Thank you. Plus 100. We add this together, that should be 829. So we have that t is equal to 6 root 829. So what's the square root of 829?
28.7.
28.79.
Multiplied by 6, what do you have?
172.7542.
172.7.
973.
What do you call the value, please?
172.7542.
So we don't have anything like that. So let's approximate to 173. The correct answer is going to be.
Okay.
You understand that now?
No. Sir, I thought we were to use this like the formula used that place we were explaining if someone's spinning vertically and um the at
This one is
how do I,
horizontal level. When you are wheeling horizontally, this is the first one I proved for you guys. Is when you are dealing with an horizontal circle.
thanks sir.
You can flash back to your notes. You can see that from the question we are told that what is wheeled round a horizontal circle. It has been stated.
Okay sir, I just noticed.
All right. Okay, so now let's take the last question for today. I just want to make sure that we are able to cover everything that has to do with this. Okay, so this one states that an object 15 kilogram, an object of mass 15 kilogram is wheeled round a vertical circle. Please note that vertical circle plus 3 meter with a constant speed of 4.5 meter per second. Find the maximum tension. Examiner can be crazy, yeah. Find the maximum tension in the string. Let's say sharp ones among you that can really understand where we have the maximum tension on it. This will be 10 meter per second square. Option A, 101.3 Newton. Option B, 179.5 Newton. Option C, 202.5 Newton. Option B, 251.3 Newton. What will be our response there?
A.
251, sir.
Okay, somebody say A, 101.3 Newton. Somebody say 251.3 Newton. Okay, let's have one person more or two person more before we jump to conclusion. But the question is at the one that will have a maximum tension. Okay. So is that the other person trying?
Yes, sir. So I'm coming.
Okay, bro.
So I got D.
And what's there indeed? 251.3 Newton. Okay. Is that the lapo?
Yes, sir.
Yeah, the one I got D right now, right?
Yes, sir.
Sir D.
This one most people got D. The person that got 101.3 Newton, kindly check your workings again. There might be a mistake somewhere. Who was the person that got what was it called? 101.3 Newton before? All right. It seems those that got D as their answer, that's the correct answer to that question. So let me just show us why it's going to be the right one. When the body is here, when the body is here, when the body is here, when the body is here. So when the body is here, we have that the tension is equals to centripetal force, and that is just mv square all over r. And when the body is here, we have that the tension is equal to centripetal force mv square over r plus the gravitational force, that is mg. And at this point we have that the tension force is mv square all over r minus mg. You get to see that the force is more maximum here, followed by this, and it is minimum at this point. Have you seen that now? So if they said the minimum force, then it's going to be this very one here. This is the formula to use. The maximum, we go for this, and that's why your result is 251.3 Newton. You can just attempt that at your leisure time. All right, thank you so much, guys, for making it to today's class. By His grace, we are going to round up now. Call it a day. So we'll meet again on Tuesday, we're going to be having physics, and on Thursday we're going to be having chemistry, and Saturday we are going to be having physics and sorry, we are going to be having biology and mathematics. Is that taken off?
Yes, sir.
All right, guys, so thank you for making it to today's class. For those that might want to watch the replay, you can do well to check the link that I'll be dropping. I'll drop it in the class, so that for those that missed the class, they can watch the replay. And like I said, we're only going to be having the replay for this week on the channel. subsequent weeks. So if you are not a member, you'll not be able to have access to this particular replay. So 2005 is not going to kill you. It's something so cheap, and it can help you blast your JAMB with ease. And guys, those of you that are in class, if you have 1 or 2 friends, let them also be part of this class. It will help us to create a community where everybody can come to learn even after JAMB, and you always try out in your exam and get a lot of things clear about physics, chemistry, and biology from now henceforth. And I wish you success in your forthcoming exam. I can't wait to start sharing your score on my status, on my pages, to show how brilliant you are. And I pray God will really make it a successful one, such that you come out in a fly color. Now, I dropped the Lamlad textbooks on the group. Please and please do well to go and attempt questions under circular motion. Attempt everything. Mind you, don't copy answer. When you finish attempting everything, use their options to mark your what's it called? To mark your workings and see how well you do. And for anyone you still find difficult or that you're doubting, drop it on the group. We'll look at it together and we'll be able to trash it together by God's grace. So thank you guys for making it to the class. I can't appreciate you enough. I'll keep on giving you guys the best. So without any further ado, you can watch my full video on circular motion on my channel. Yeah, so I have a full video on circular motion. I think it's going to be the first video you are going to, because I think I pin it to that channel. You can watch it to have more exposure about this. So everything in that video is what I've summarized in this class, but you can just watch it because it's just a lecture. All right, guys. So see you.
Sir.
I'm with you.
Sir. You mentioned solving 2011 of the physics past question. I couldn't find it in channel. Can you help us drop the link in the group?
Which link is that? That is the link to the past question.
Yes, sir. The 2010 you said.
No, the past question consists of 2010. I think from 2010 to, can you see the screen now? From 2010 to
Yes, sir.
2018. So it's already,
Yes, sir.
yeah, it's already on the group, but I will share it again, should in case you miss it. But it's already on the group.
No, I don't mean the question. You said before that you have done the
Okay, 2010, right?
2010 as in you have answered them in the
Okay, I get
in
your
your channel.
I get your
Yes, sir.
question now. I'll try and check for it so you can have access to it also. Because it's specifically for paid member of the channel. So I'll try and get it
Thank you, sir.
across to you guys.
Okay.
Okay, guys, wait. Before you people leave, what will be the answer to this question? Now, the question that leads us to the class. What will be the answer to it? Can't go without answering it. An object of mass 2 kg moves with a velocity of 10 meters per second around the circle of radius 4 meters. Calculate the centripetal force.
Which one?
Can you see the screen? Okay.
50.
You'll be what?
50, sir.
50.
50
50
Newton.
Newton.
50 Newton.
50.
Okay, can you just check? Okay.
50.
Okay. That is 200 divided by 4. Yeah, absolutely. 50 is going to be the right answer. So thank you so much. See you guys in the next class.